1859, telegraph operators watched sparks leap from their machines, and some offices caught fire in the middle of the night. Operators reported electric shocks from their own equipment, while overhead the night sky burned red and green as far south as Central America. Here is the strange part. Some telegraph lines kept sending messages after operators disconnected the batteries. Remember that detail. It explains everything. The night before, a British astronomer named Richard Carrington had been sketching sunspots when a blinding white light flashed across his telescope. Was the sun hurling a huge cloud of electrified gas at Earth at up to 2 million miles per hour? It became the most intense geomagnetic storm ever recorded. The telegraph was nearly the only electrical technology on the planet. Today, we have wrapped the entire planet in wires, satellites, and signals. Scientists agree a storm that size will happen again. To understand what it could break next time, you first need to see what actually happened on the sun that morning. The sun runs on an 11-year cycle. Its magnetic poles flip, sunspots multiply, and its surface grows violent. Astronomers call the peak solar maximum. During solar maximum, the sun throws more flares and eruptions than at any other time. Right now, we are living through one. The biggest eruptions are called coronal mass ejections, gigantic plumes of energized gas and dust blasted into space at millions of miles per hour. Most miss us completely. When a direct hit arrives, it slams into Earth's magnetic field and temporarily distorts it, shaking the invisible shield that protects the planet. That shaking is the weapon. A moving magnetic field creates electric current in any long wire it passes over. This is basic physics, which finally explains the ghost telegraphs of 1859. The storm itself was pushing current through the lines. The batteries were never needed. The same shaking paints the sky. Charged particles spilling into the atmosphere glow green and red, the aurora, beauty and threat in one. And we know none of this is theory, because for the last 40 years, the sun has been quietly running rehearsals on us. March 1989, a solar storm drives currents into the power grid of Quebec, Canada. Transformers trip, and the whole network collapses. 5 million people lose power for 9 hours. One storm, one grid, gone in minutes. And this storm was far smaller than Carrington. Quebec spent over $1 billion hardening its grid afterward. Hold that thought, because there is a catch buried in that billion. May 10th, 2024, a storm called the Gannon storm hits, the first extreme G5 warning issued in over 20 years. Auroras flood the sky, operators of power grids and satellites scramble, and researchers collect precious data on how our systems actually respond. November 11th, 2025. Northern lights appear as far south as Alabama and Florida, and people across America look up in awe, what most of them never hear. That same storm blacked out high-frequency radio across Europe, Africa, and Asia for 30 minutes. It also delayed the launch of a NASA satellite mission. Every rehearsal so far has been a fraction of Carrington's size. Break something we rely on. A true Carrington-class storm launches from the sun today. Here is what the next few days look like. The first punch travels at the speed of light. Within minutes, radio signals start failing, just as they did last November, but harder. Then the main blow. A coronal mass ejection crossing space at over 1,000 miles every second arrives and hits the magnetic field. Up in orbit, the atmosphere absorbs the energy and swells outward. The European Space Agency estimates satellite drag could spike 400%. Tens of thousands of satellites suddenly plow through thicker air. They slow, they sink, and some begin falling out of orbit entirely. GPS signals scramble. Commercial flights, defense detection systems, ships at sea, even the watch on your wrist quietly lose their sense of place. Astronauts shelter inside their station, postponing anything outside. And through undersea cables and long landlines, Geomagnetically induced currents begin to flow, hunting for the data centers at the ends. But orbit is only the opening act. The real damage happens on the ground, inside machines most people have never even seen. They are called high-voltage transformers. They run the world's grids, and they are why this story is measured in months, not hours. Days look like. A transformer is the heart of a power grid, stepping voltage up and down so electricity can travel from plants to homes. Storm currents exceeding 100 amperes can slip into the grid and cook those transformers from the inside, the way Quebec learned. When enough of them fail, the failure spreads. One collapsing section overloads the next. Engineers call it cascading failure. It moves fast. Estimates suggest millions of people could lose power not for 9 hours this time, but for weeks or even months. Experts warn the outages would cascade into healthcare, water and sanitation, and the financial system, because every modern system leans on another. Now the catch in Quebec's $1 billion. Experts warn most grid protections built so far are geared for storms smaller than Carrington. It sounds like a story with no exit. Except the sun, for all its violence, hands us one strange gift before every attack: a head start. The storm announces itself, and the hours between the flash and the blow are where survival actually lives. Weather satellites like the GO series stare at the sun around the clock, watching for flares and eruptions the moment they happen. With warning, grid operators can protect transformers, satellite operators postpone risky maneuvers, and astronauts stay inside. The shield is information, not steel. Agencies now run training exercises for a Carrington-scale hit, rehearsing their response the same way coastal cities drill for incoming hurricanes. For the rest of us, preparing looks refreshingly ordinary. The storm is, at street level, simply a very long blackout. Water, food, light, a plan. Carry it through a solar storm. What are the odds? One study puts the chance of a catastrophic storm in the next decade at up to 12%. The sun will do what the sun wants. So the storm of 1859 was never really history. When the sky next glows where it should not, you will know what it whispers. Next time, the day Earth's magnetic shield flipped.